going to talk about how to safely kill tasks in Gerrit. As usual, you can join us lighty.com. If you haven't done it, you can scan the QR code and you can ask your questions or chip in with some of your experiences. So we're going to talk about killing tasks in Gerrit. And so let's start from when would you want to do that? So when you would want to kill a task in Gerrit? Well, there are actually many scenarios in which you might be tempted to do this, right? Maybe you want to abort a lengthy operation. The operation is Gerrit that is taking a usually long amount of time, is consuming your resources. Maybe you're seeing your monitoring tools that the CPU is spiking up, or the memory utilization. Maybe the operation is a fetch operation that is taking too long. If that happens, probably you need to do some retuning to your timeouts and deadlines in Gerrit, because no fetch operation should ever take longer than you allow it to. So if you have something that is got so long to go beyond what's acceptable to you, instead of killing it, you should really think about maybe do some retuning in Gerrit. Maybe you have a client with a slow connection and it's consuming one precious thread from your SSH thread pool, and you don't want to allow that. Maybe you want to prevent a scheduled operation from happening. In Gerrit, you can schedule some operations internally. If you have any good reason why you want to skip one of those ones, you might decide to kill that before it actually gets executed. Or maybe you just realize that there's something running that you shouldn't really have to, because you misconfigure it somehow. There is no point in letting it run, or it can even be harmful if that was happening. So really, there are many reasons why you want to decide to kill something in Gerrit. But the question you should be asking yourself is, well, is it safe? Like, can you actually kill an operation in Gerrit, and what are the consequences of it? And like, are you making the situation better or worse, and what you should be considering before you do that? So today we're going to talk about that. And the answer, obviously, like many things, is it depends. And this is especially true for Gerrit. It really depends on many factors, and we're going to see some of those. So the first interesting thing is, like, what are you killing? So you really need to understand exactly what is the nature of the operation that you're trying to stop. Because depending on the nature of that operation, the activity that you perform for killing and the approach is different. And in order to understand exactly what you are killing in Gerrit, you need to understand how things are executed in Gerrit. And Gerrit is a Java-based application, so obviously you all know it runs on the JVM, and as usual, as new operations get executed, you have new threads running on the JVM. However, Gerrit has a higher level of abstraction that you can use on top of that, which is called the work queue. The work queue is basically a tiny wrapper around the executor service, and basically allows you to submit tasks to a blocking queue. So the task will be submitted to a queue, and they will be associated to threads available in a thread pool. As soon as one of the threads is available for to execute one of these tasks, this task will then be executed by the thread. This work queue object, if you ever looked at the source code of Gerrit, it's something that you will see pretty much everywhere. Anytime Gerrit wants to perform something asynchronously, it will use the work queue to submit the task. And what the tasks they are submitted by using the work queue are also hydrated with a special unique identifier that you will be able to see when you run a show queue command. So if you ever run that command before, you will see a list of tasks associated to an ID, and those tasks are the tasks that are submitted using the work queue. Ultimately, however, everything runs as a thread in Gerrit. So it changes the way this is produced, but eventually this is executed as a thread. So what does it mean for us? That when we are talking about canceling or stopping or killing things in Gerrit, we are actually talking about canceling or stopping or killing a thread. And how can you see the threads? How do you even know what exactly is running in Gerrit? Because in order to decide, to pinpoint which task you want to stop, you need to be able to do that. And you see threads in Gerrit as you normally do with any Java-based application. So you can use a JStack and you can pass the Gerrit process and it will tell you which threads are running. JCMD is another way to do it. You have plenty of tools out there to do the same. You can even use the Gerrit.sh threads, which will output a textual representation of the threads that are running in Gerrit. Or you can use Java Melody. How many of you know about the Java Melody plugin out there? Okay, so Java Melody is not a core plugin. However, it's one of the most used plugin out there, simply because it's really, really easy to install. It's a tiny wrapper around the Java Melody library. And the benefit that it brings in is immense, because it will really give you visibility on the status of the Gerrit process, and you can do really many things about it. You can understand how healthy is your system by looking at the resource utilization, and also conveniently it will give you a list of threads that are currently executed. For each thread you will see their state, you will be able to see the stack trace of what's been executed at that point in time, and crucially you also have the ability to interact with these threads. So you have the ability to interrupt them or to kill them. So what's the difference between these two actions, and why should you prefer one rather than the other? So when you hit the kill button, basically what Java Melody does, it will call thread stop on that specific thread that you chose. And the thread stop cannot be handled, is an abrupt termination of the thread. You're not going to give the thread the possibility to do any cleanup after itself. So it will not be able to close any resource that was open, and which can end up basically in leaking resources. If you have database connections, log files open, you're gonna end up with those resources not being closed, which is obviously not ideal and quite risky, depending on what was the nature of the activity that was happening. And crucially, the thread that you're killing is not going to go back into the thread pool where you got it from. And that's really important, because you have very limited resources. If you have an SSH interactive thread pool of, I don't know, 32 threads, you're killing one, well, now you have 31. And now if you do this in production, your users will need to cope with only 31 threads. So if you keep doing this over time, you're actually running a degraded version of your Gerrit installation in production, which is not ideal, and you might get to a point where it's not able to sustain the load anymore. You can also choose the interrupt button in Java Melody, which calls the interrupt method on the thread, which basically sends a signal, and this signal can be handled. And what it means is that when you're sending the interrupt signal to your thread, the code, the implementation of the thread might actually decide to do something about it, and he has the opportunity to do a proper cleanup of the resources that were open. The cool thing about interrupt is that all the standard classes in Java already are able to handle them. So depending which part of the stack you are, if the standard libraries will be able to automatically understand that an interrupt signal was sent and handle that. But the flip side of this is can also be ignored. So when you click on the interrupt button in Java Melody, you have no guarantee that this is actually going to stop your thread. You might have some handling interrupt method that will receive the signal and it will just decide to do nothing with it. So you will end up with a thread that actually is still actively running. However, if you remember the thread model that we explained before, you would remember that Gerrit has the ability of creating tasks using a higher level of abstraction, which is the work queue. And when you create a task using the work queue, which, as we said, will hydrate the thread with a special ID, you can actually grab that ID that was created, and you do this by looking at the show queue, and you can ask Gerrit directly to do some proper cleanup of that task. And ultimately, the task, the thread that is being created will eventually be terminated. But in this case, you're not going behind Gerrit's back. You're actually asking Gerrit to do the killing for you. And when you do that, you actually have a better chance to do the proper thing. And you do this by using an SSH command, which is the kill command that is available out there, which will cancel the task created by the work queue. So you can inspect by the show queue and pass the ID that you retrieve from it. Not everybody can do this. You need to have a kill capability to be able to do that, or you need to have to be a server maintainer. So it will call a method that is implemented in Gerrit, which is a cancel method, which we will dive in a little bit, which will give an opportunity to your code to actually perform a proper cancellation and actually clean up after itself. In order to understand exactly what's cancelable, what's not cancelable, the implementation of the task can provide a cancel method by implementing a cancelable runnable interface that you will see in Gerrit. When you do that, you give your task the ability to handle a cancellation before the task gets executed. This is like the easy approach, because if you have a task that is waiting in the queue, you can just you decide to kill it before it gets started. Very likely there are no resources to be cleaned up because the task hasn't started, and then basically you can just remove that task from the execution. So in that case, it will be in the blocking queue that we've seen before, and it will not be executed at all. And here it's just an example that is taken from the Gerrit core. This is specifically from the push replication, in which if someone killed the one of the distributor tasks, it will just interrupt any. It will interrupt the thread before it even gets executed. You can also, you might decide to cancel a task. However, it might happen that task was already being executed. So in that case, you want to provide your task the ability to be terminated during the execution. If you think this example is taken from the push replication again, and is the implementation of the push logic, and if you have a git receive back, a push that is pushing your code to some replica, you decide to kill that task is going to fail, and because it's going to fail, the push replication is going to retry, and that's exactly what you want, what you don't want, right? You just killed it. You don't want another retry of that. So you can actually embed a logic here that will prevent that task from being re-executed. So when you implement the cancel while running logic, you give the ability to your task to do the right thing when it was already in execution. And in this case, is to stop retrying, because you don't want that to, and you don't want to try that again. And also you have the opportunity to close any resources that were open. Okay, quick demo.
So what I did, I actually prepared a very small plugin. You will remember Danny's presentation earlier on about how to write plugins, and Groovy was one of the languages he mentioned to do so. And here I have exactly a Groovy plugin that implements 3 different classes. They have the ability of executing long-running tasks. It's actually very simple. There is a little bit of boilerplate, but I would like you to focus in on this part, which is the core of the task that gets executed. So in this run method, what we do, we create a new resource, we log some stuff in the log files, then we just sleep for the configure amount of time, and then we wake up, and we do the cleaning of the resource that we opened. That's it. But I have three flavors of this plugin. One that creates a Gerrit task through the work queue. One that creates a task that is actually cancelable. So in this second flavor of task, you will see that we are implementing the cancelable runnable, and therefore we must implement the cancel method. And then we have a third flavor, which is where we implement the cancelable cancel while running. So we also need to implement the set canceled while running method. I'm going to show you a quick demo of how these behave differently depending on how they get executed. So here in the middle, we have the Gerrit queue. So this is going to show us the tasks as we create them. And I'm going to create one. So this is a long running task, for example, that will last for 5 seconds. As we run this, you will see that the task now appears in the queue and is set to run for 5 seconds, and it creates a resource. And here in the log, you can see how this is also logged. When the task, after the task has slept, it will wake up and it will clean up after itself. But now the question is, what's going to happen if we just terminate, if we kill this task in between? Well, let's try. So let's create a very long running task. Say this one is going to last 2 minutes. If we head to Java Melody, we can see what's going to happen if we. Okay, so we can see here this task is being executed. We know this is the task because you can actually see from the stack trace that this is what it's been executed. So let's just click the kill button, which is this one, sorry. So we kill. As you can see, the task has gone from the queue. You can no longer see it. However, the cleanup has not been executed. We're going to do the same thing with the interrupt now. So the task has been executed. This is the resource that is being opened. We're going to head to Java Melody. And we are going to now see the behavior of the interrupt. So we find the right thread and we call interrupt on it. This is going to send a signal that we will handle. There you go. Our task has been interrupted. So we managed to do the cleanup, which is really cool because that means that we actually had the opportunity to clean up any resource that we opened. The other two flavors that I wanted to show you are these ones. So we have the long-running cancelable task. So this is, so we're going to execute this cancelable task. Now this is being, okay, so this is the task that is being executed. Okay, I think I found a bug in my demo. Okay, so if we kill this task now using the kill command, we need to use the ID that is being added by the work queue, and you can see that the cancel method has been called. So we actually had the opportunity to do the cleanup.
So the question is, when you run, say again.
So when you cancel a thread, or when you cancel your work queue item, which thread does the cancel method run on?
Okay, so the question is, when you cancel your task, which thread gets terminated, right?
Or which thread runs the cancel method?
Which thread runs the cancel method? It will be well, when you run the kill command. Actually, it's a really good question. I will show you. The kill command, it's actually very simple. The kill command is here, and so it will run in its own queue. And so when you run commands in Gerrit, there is a dedicated thread pool that is down to the execution of those commands. And what it does basically, it will do the parsing based on the string that the ID that you're giving, and basically will call this apply. And then when you call this apply, here, you will see how it's calling the cancel method. And this is where the magic happens. This is where it will behave differently depending on the implementation of your task. And that's why it's important that you do implement these interfaces, because it will, here and here, you will have the ability to, here and here, you will have the ability to clean up after yourself.
So then you can actually hit a deadlock if you if your thing is mutex protected. So if you're not careful, you can have a deadlock in your cancel method. Your thread will actually be stuck forever.
Yes, I guess there is the possibility. Yes, and also, but you mean for the execution of the
the execution of cancel. So if you hit cancel and you hit a deadlock, then your thread won't actually be canceled.
Well, your thread. So the question is there a possibility to be in a deadlock when you run the cancel method, because the execution of the cancel method will be on a different thread pool than the target itself. I'm not sure, actually. I'm not sure. Why do you think there is a
suppose if you don't need to acquire the mutex, then you're fine. But
the mutex on what resource?
If you whatever resource you like from that.
You mean in the cancel itself, in the implementation of the cancel?
Yes.
You mean, okay. So the question, yes. So the question is, so when the cancel method is executed, depending on the resource that you're doing cleanup with, you might actually end up in a deadlock. Yes, if you're blocking on that resource, for example, that's a synchronized resource. Yeah, you will need to keep that in consideration when you implement the cancel method. Okay, no more questions then. Thank you guys. Thank you for coming.